What's up, guys? Today I wanted to talk about Kirchhoff's voltage law, or KVL. And what KVL is it's a circuit analysis tool that we use to analyze series DC circuits. And you use it when you want to find a voltage across an element in a series circuit. So, what Kirchhoff's voltage law says is that the sum of voltages around a loop is zero, or the sum of rises in voltage equals the sum of the drops in voltages. So if we look here at the voltage source is 32 volts. So what we're going to do, we know that the current goes out the positive side of that voltage source. So it's going to flow clockwise. So what we're going to do is we're going to start at ground, and we're just going to follow this loop around in the direction that the current goes. So we start at ground, we're going to go up 32 volts across the voltage source. We're going to go down 12 volts across resistor 1 because we're going from high to low. Then we're going to go down some voltage drop across resistor 2 that we're going to solve for. And then we go down 14 volts across resistor 3, and then we're back to ground. So let's go ahead and do that. So if we start at ground, we're going to go up 32 volts. And then positive to minus, we're going to go from high to low, so we're going down in voltage, so minus 12 volts. 12 volts. Minus V2, we don't know V2 yet. Minus 14 volts. Equals 0. So if we bring V2 over to the 0 side, we're going to get 32 volts minus 12 volts minus 14 volts equals V2. So when you solve for that, you're going to get that V2 equals 6 volts. So what that's telling us is that the voltage drop across R2 is 6 volts. The difference between the positive terminal and the negative terminal is 6 volts. So if you're taking a circuits course, you're going to use KVL a lot to find unknown voltages, and then it just becomes a starting point. You know, you'll use it for lots of other things. So you'll solve for the voltage and then move on to other things. But KVL is a very important law in circuits, so it's really important that you practice it and get good at using it. So to summarize, essentially you're just gonna follow the rises and drops around a loop until you return back to where you started from, and then just solve for the unknown voltage.